Hello class, this is the exclusive tutorial. So this is the continuation from the last topic I taught capacitance. I've explained the theoretical aspects on it, and this is the follow-up calculation questions I'll be seeing for this part. So our question today says, what is the equivalent capacitance between point M and N in the circuit below? So this is the diagram for the circuit. So if we are to break the circuit to a smaller or a more appreciable way, so we can just or reduce the circuit to its most equivalent value. If we are to reduce the circuit to its most equivalent value, first of all, we'll be considering the series and parallel nature of the circuit. So first of all, if you look at these two, this 12 microfarad and this 6 microfarad, you notice that they are connected in series with each other. And for my last class, I said when it comes to series connection, in order to calculate the equivalent, 1 over C total is equal to 1 over 12 plus 1 over 6. That is, from the formula, 1 over C total is equal to 1 all over C1 plus 1 all over C2. Following that formula, so from there, if we're looking for our C total, the equivalent capacitance, we'll now say 12 times 6 all over 12 plus 6 from the formula. So to give 12 times 6, which we don't know the value, all over 12 plus 6 will give us 18, which we are sure of that. 3 can go here, 3 can go into this one too. 3 can go here, 6. 2 can go 1, 2 can go 3, and 3 can also go here, 4. So the effective capacitance at that point is 4 microfarad. So if we want to now draw the diagram, it will now be giving us something of this nature. Something of this nature. Do you know something of this nature? This time it's now just a single capacitor that is found here, and it is 4 microfarad. And for this one, 6 microfarad, and for this one, 6 microfarad, for this one, 9 microfarad. In order to prevent all this drawing and drawing again, let's just solve it without doing the drawing. So for this part, it is connected in parallel to each other. Why is it connected in parallel? The wire, the conductors or the wire connecting the 3 capacitance here are different entirely. So the quantity of the charge is somehow different in this sense, but the voltage in parallel connections are similar. So, but in parallel connection, for calculating the effective capacitance in parallel connection, we are just expected to add everything there. So it will now be 6 microfarad plus 6 microfarad plus 4 microfarad. So if we are adding it, 6 plus 6 will give us 12. 12 plus 4 will give us 16 microfarads. So we are left with 16 microfarad and 9 microfarad. So from there, this is what the diagram will give us. Just this. 9 microfarad, 16 microfarad. If this connection is now a series connection, so if we are to solve this series connection, we are going to solve it this way, using our normal formula. 1 over C22 equals to 1 over C1 plus 1 over C2. So our CT is equal to C1 times C2 all over C1 plus C2, which is 16 times 9 all over 16 plus 9. If you are going to solve this, we'll be having 5.6 0.76 microfarad as your answer at the end after solving. So that is that for the first question. And for the other question, they said, what is the magnitude of the electric field required to store the electric potential energy of 2.5 joules in a vacuum of 1.00 meter cube? That is the volume they are talking of. So when the question here we are given the energy, and also there is also a volume, that brings in mind the energy density, which is equal to our U, which is energy. We're told to calculate the electric field, which is the energy stored divided by the volume. So first of all, we're giving our potential energy when we're also giving volume. So what simply comes to your mind first of all is the energy density, which is the charge divided by the volume. So if we were to solve this, it will give us 2.5 divided by 1.0, which is equal to 2.5 joules per meter cube. From this part, we're told that we're given just the energy and the volume, which we used in calculating, which we used to calculate our energy density, and we're told to calculate the magnitude of the electric field. And remember, from our formula, U is equal to 1/2 K U naught E square. From the question we are given, it's very obvious that the system is in a vacuum, and whenever we are dealing with a vacuum system, the permittivity constant is not required, so our U is therefore equal to 1/2 U naught E square. So from there, we have to calculate the electric field. If we are to make the electric field the subject of the formula, it will give us 2U, making U over 1 cross multiply to be 2U all over U naught is equal to E square. So from there, our E square is equal to, our E rather is equal to the square root of 2U over U naught. So if we are to imply the values, we therefore have that our 2 bracket 2.5 divided by our constant permittivity of space 8.85 times 10 raised to the power minus 12. If you solve that correctly, we'll be having 7. Since it's electric field, so we'll be having 7.52 times 10 raised to the power 5 Newton per coulombs as your answer. So the big part of the question, let's solve the big part of the question. So the big part of the question said, if the magnitude of the electric field is increased by 500%, so our E1 is equal to the E normal, which is the value we got there, which was 7.52 times 10 raised to the power 5 Newton per coulomb. They said if the magnitude of the electric field is increased by 500%, that is, our E2 is therefore equal to 500% of our E1, and our E1 is 7.52, so it will now be 500 all over 100 times 7.52 times 10 raised to the power 5. Definitely this will cancel out this. We'll be left with 7.52 times 5. We'll be having 3.76 times 10 raised to the power 6 Newton per coulomb. You can also use volt per meter because you are dealing with electric field. Then they said how much energy is now stored per cubic meter. So at first, our U is equal to 1/2 U naught E square. We are just interested on these two quantity, our U and our E. We have to make every other quantity constant at this point in time, because we were told that the magnitude of the electric field is increased by 500%. Then what is now how much energy is now, that is what is now our energy density. That is what they are trying to they are trying to tell us here. So if I'm to make these guys constant, let's make them K. The whole of this part, let's make it K. Now be left with U square is equal to U, making the whole of this one equal to K as a constant. Then from there I can say U all over H square is equal to K. From here I've gotten an equation that I can use to relate both our E1 and our E2. So I can say our U1 all over E square here. So our U1 all over E square 1 is equal to our U2 all over E2 square, where our U1 is equal to 2.5 joules per meter cube. I cleaned that part from the board initially. So if I place our U1 2.5 divided by our E1 square, our E1 was this 7.52 times 10 raised to power 5 all square is equal to our U2. Our U2 is what we are looking for. This is not in square. Our U2 is what we are looking for, divided by our E2 square, which is equal to, what is our E2? 3.76. 3.76 times 10 raised to power 6 is our U2. So if I'm to make our U2 the subject of the formula, our U2 will therefore be equal to our 2.5 times 3.76 times 10 raised to power 6 divided by, remember this one is squared, divided by our 7.52 times 10 raised to power 5 all squared. Remember this one was squared like I said earlier. So our U2 therefore be equal to, if you punch your calculator, our U2, you'll be having our U2 to be equal to 62.5 joules per meter cube as your answer. So that is what we have for the calculation aspect for our capacitance. Our next topic we'll be taking on will be the dielectric, that is the insulating substance found between those capacitor. So if you have any question, you can just drop it on the comment section. You can drop it on the comment section. In the next video or any other videos we'll be doing, I can just create a separate video where I can answer several of these your questions you placed in the comment section. So you can watch those videos and have a better understanding of that part. Thank you.